This tutorial is going to go over how to do sex-linked traits. So remember, with sex-linked traits, we're only talking about those traits that are on the X sex chromosomes. So you guys have to remember that females have XX sex chromosome and males have an X and a Y. So the first example problem is referring to hemophilia, which is a blood disorder. It is X-linked recessive. So capital H stands for normal, and then lowercase h is the allele for having hemophilia. So in this example, they want you to cross a female who is a carrier with a normal male. So just to review, if you are a female, you can have this genotype. So this would be a completely normal female. Or you could have this genotype, which is the carrier. Or you can have a female with hemophilia, which looks like this, okay? They're telling us we want to cross a female who is a carrier. So in that case, we don't need this one, and we don't need this one. So here's your genotype for a carrier. Then you're going to cross it with a normal male. So just to review, males can either have this genotype or this genotype. This one would be hemophilia. We don't want that. We want a normal male. So I'm going to get rid of this one. Okay? So these are the two individuals that you are crossing. Okay, so we're going to have to put the female and the male on the Punnett square. Does not matter if you put the female at the top of the Punnett square or on the side. So I'm going to just put the female here to the left. So again, you put the XX, and then I put the alleles for hemophilia on the X's. So capital H, sorry, and then lowercase h. Okay, and now I'm going to put the male on this one. So I put the X, and the capital H goes on the X. That's why it's called sex-linked or X-linked. And then nothing ever goes on the Y. Okay, so then you're just going to bring them together. So in this case, I'm going to bring this one and this one together inside the box. And you guys can show dominance here because they're both capital H's, so it doesn't matter. But then for the next one below it, put the X with the capital H first to show dominance, and then put the lowercase one. So that's the way you would fill out your Punnett square. Now we need to analyze this. So that's where you can find the genotypic ratio, phenotypic ratio, and you'll be asked probability problems. So genotypic ratio, remember the genotype is the letter combinations. So again, you have to write the XX and the XYs for the male and the female, and then you have to show the alleles on the actual X's. So I would just start the top left box, and I would count how many of each we have. Well, I only have one of those. So I'm just going to write 1, so then I would move to the next box. I have one of those. It does not matter what order you write these in. So then I move to the next box. And then finally the last box. I'm just going to have to put it here because I'm running out of room. So you would have a 1 to 1 to 1 to 1 ratio, and then just make sure you put the XX and the H combinations when you're writing your ratios. So then the phenotypic ratio. So when you're writing the phenotypic ratio, this is where you're going to have to say whether it's a male or a female, if they have hemophilia or no hemophilia, if they're totally healthy, or maybe if they're a carrier. So again, I'm going to start with the first genotype up top here. So you would say this is a 1 normal female. Okay, then I move on to the next one. All right, well, that is a normal male. You could even say like healthy male. So 1 normal So that means he has no hemophilia, because remember, hemophilia is recessive. Then I move on to the next one. Okay, this female, it's important, especially when we're talking about diseases or disorders. She is healthy, but because she has this one lowercase, that means she could pass that on to her child, which means if that is a male and she passes that on to her son, he automatically has the disease because he only has one X. So what ends up happening with sex-linked traits is that oftentimes the females are the carriers and they pass it on to their sons. So you would want to make sure when you're writing the phenotypic ratio, you need to state she is a carrier. That is important. If you're having a child, you would want to know if you're carrying a disease or not. So I would say one carrier. Geez, it's not letting me write. Hold on. All right, fine. Let me write. Okay. And then the last one, right here, this would be a man with hemophilia or son. So one. So there's your one hemophilic male. Or you could say one male with hemophilia, any way you want to state it. Okay, so in this case, you would have 4 different phenotypic ratios. So then would be probability questions. Now, with the probability questions, they can ask out of all the children, like what's the probability out of all children or having a child, or they could just ask you specifically between males and females. Okay, so say it asks you what's the probability a child has hemophilia. Then you would look at all 4 of the boxes. So the only one that is hemophilia, again, would be this one here or here. So you would say 1 out of 4 or 25%. So these parents would have a 25% of having a child with hemophilia. Another probability question could be, what is the probability that a male child will be normal? So we're just talking about males. You're only going to be looking at the 2 actual males in your results. You're only going to look at this one and this one. So out of these 2, 1 is normal. So the probability would be 1/2, or you would say 50%. So you're only going to look at the 2 males here. Another sex-linked trait that we're going to talk about is color blindness. So again, it's X-linked recessive. So big B stands for normal, little b stands for colorblind. So they want you to cross a normal female with a colorblind male. So she's completely normal, she's not even a carrier. So she would have the genotype. And again, now we're using B's. Okay, so that's the female. And then the colorblind male genotype would look like that. So then you're going to put it on the Punnett square. Does not matter if you put the male or the female. Like you could have put the male on the left side or you could put the female above. It doesn't really matter. Just make sure you separate the alleles. So then you fill in the box for their children. And then we're going to find the genotypic, phenotypic ratio, and some probability problems. All right, for the genotypic ratio, it would be 1, 2 of those. To then 2 of these. All right, phenotypic ratio. So do they have the trait or don't they have the trait, or are they carriers? So remember, females are the carriers. So if we're looking at the first genotype, that would be a carrier. So you would say 2 carrier female to then 2 normal vision males. So then an example probability problem would be, what's the probability of having a colorblind child? Well, in this case, there are none that are colorblind. So you would say 0 out of 4 or 0%. So remember, if they're asking for children, you're looking at out of all 4 boxes. But if they just say like male child, you're just looking at the 2 males. And if they say females, you're looking at the 2 females. So another example would be, what's the probability of having female children who are carriers? So for us, we have 2 carriers, but we also have 2 females. So if they both are, it would be 2 out of 2, or 100% of the female children are carriers. I hope this tutorial helps, and if you guys have any questions, please reach out.